Understanding the 3 address lines.
Hello everyone! Today we're going to delve into the fascinating world of computer architecture, specifically the necessity of having 3 address lines in certain instructions and what information each line should carry. Having a clear grasp of this topic will greatly improve your understanding of how processors execute instructions, so let's dive right in.
What are address lines?
Address lines are paths through which a processor or a controller can select a particular memory location where data is stored. The number of address lines a system has determines the amount of memory that the system can address. In the context of a 3-address instruction, these lines don't exactly correspond to memory addresses, but rather, they refer to the addresses of the operands and the result.
Why 3 address lines?
The reason behind having 3 address lines stems from the nature of arithmetic and logical operations that CPUs perform. Most of these operations are binary, meaning they involve 2 operands. So why 3 lines instead of 2? Here's why. 1. First address line, source operand 1. The first address line is used to specify the location of the first operand. 2. Second address line, source operand 2. The second address line is used to specify the location of the second operand. 3. Third address line, destination operand. After the operation is performed on the 2 operands, we need a place to store the result. This is where the third address line comes in. It points to the location where the result should be stored. The beauty of a 3-address instruction set is its simplicity and efficiency. It allows us to perform an operation and store the result all in one instruction.
What information should each line carry?
1. First address line. This carries the address of the first source operand. This could be a memory address or a register address, depending on the architecture and the specific instruction. 2. Second address line. Similarly, this carries the address of the second source operand. 3. Third address line. This carries the address of the destination operand, i.e., where the result of the operation will be stored. The specific information carried on each line might vary depending on whether the architecture uses immediate addressing, direct addressing, register addressing, or some other addressing mode, but the general concept remains the same. Understanding the need for 3 address lines and the information they carry is crucial to get a good grasp of computer architecture and instruction execution. Always remember, the first 2 lines typically carry the addresses of the 2 source operands, and the third line carries the destination address where the result will be stored. Knowing this is your first step towards mastering the art of low-level programming and hardware optimization. Happy learning!